All right, my name is Kevin Grossnicklaus. I'm going to talk to you today about Webpack, introduce you to what Webpack is. We're going to spend an hour. Like I said, it's going to be very demo heavy. I'm going to show you, I'm going to give examples, different projects, everything I'm going to show today. I'll share a GitHub repo with you. First thing you notice is I have my contact information up here. If you were in the last session with Spencer, much like him and many of these other speakers here, I'm more than happy to respond to emails, Twitter, DMs, anything. If you walk out of here and you say, man, I wish he would have talked about this, or he alluded to this but didn't give a demo of it, or what should I be doing next, shoot me an email. And if I don't respond right away, I apologize. I get a lot of emails because I share my email a lot. So it's not because I'm ignoring you. Sometimes things fall through the crack. Just ping me again and say, darn it, I asked a question. And I will definitely get back with everybody who writes me. I also have cards if you want a card, but it's to get that email. So to kind of level set in, how many of you have used Webpack? Anybody here come in here with experience? Good. So a number of you actually. That's a growing number. It's becoming more and more popular. I've given a similar talk or included Webpack in talks that I've given for a couple of years now. And 2-3 years ago, if I'd asked that question, you'd have got one person. It was something people had heard of. I work for a company called Architect Now in St. Louis. We're a product development shop. So we build mobile apps, web apps. We help people launch software products. Webpack is a big part of what we do. We're also an Angular shop. So I will admit that lately, all of our Angular apps are using Angular CLI. Anybody here use Angular? Angular CLI, a number of you? I'm going to demo that if we have time at the very end, but still uses Webpack. They just hide Webpack from you if you use the CLI. So we spent many years writing our own Webpack scripts. It wasn't a full-time job by any means. As you're going to see in this talk, or as you probably know, the many of you that have used it, Webpack is nothing you code in. It's just a tool that is part of your development chain. It takes your assets that go into a web project, whether it's JavaScript mainly, but your CSS, your Sass, your images. It manipulates your assets as part of the development process. We use Webpack heavily every day as we code. Developers have it running Webpack Dev Server, and we edit code in our favorite editor, and we see the results in our browser immediately refresh. When it comes time to do a deployment, Webpack is part of that. We publish it. It runs a different pipeline. It compresses things, minifies things, and then it pushes all of our code into a smaller set of files called bundles, and those bundles are the things that ultimately go out to our web server in production or stage or wherever they may go. So we got really good at Webpack, and by we, I mean one guy on my team, not me. Webpack was brought to my team. I have a young kid working for me. He's 24, he was the youngest. We just hired a younger kid. They're getting younger and younger, and I'm getting older and older. This kid was a Webpack expert, and he set up Webpack for us, taught us all how to use it. And honestly, we had a pattern that when a new project starts, we take the Webpack config files and move them. It's nothing that we modify significantly. And that, I would assume, is very consistent with how many of you who use Webpack and how you use it. Nobody sits and tweaks it every day. If it doesn't do what we want it to do, somebody figures that out and makes it. I'm going to explain all the concepts of Webpack, give you some demos today. But ultimately, whether you use it or not, if you go back and decide that this is something that's going to benefit my team, somebody who's going to have to figure out how to set up these config files, get the process tweaked and working, and then distribute it to everybody else. What else from a housekeeping standpoint? I have an hour. I'll be happy to answer questions as we go, but I'm going to dive right in. Those of you that got here early, I know the screen is not super huge given the size of the crowd in the room, but I apologize. I'll try to make my fonts and everything else as big as possible. I'm going to do stuff in command line. Webpack has a very nice website, some very nice images. I always show this image. Webpack is a module bundler. Many of you, and my team was the same way. Prior to using Webpack, we still did these things. These things are important as part of your development process. We use Grunt, we use Gulp, other scripting tools. So we had other ways of achieving these goals. Webpack came along, we quit using those other tools, and we achieved those goals using this tool. Webpack is a command line tool. It's a command line tool that you can pipe parameters into, or you can give it a config file that is a module that can do everything. We're going to do both today. But Webpack takes pieces of your web development stack. When I say pieces, it takes assets that have dependencies, JavaScript, TypeScript, your CSS, images. It runs them through a pipeline or its configuration, and it outputs a smaller number of assets, so it doesn't lose anything. It takes everything, this big mess they have on the left, and it bundles them into smaller packages. Why do you do that? There's a number of reasons. Efficiency, it minifies things. Less chatty websites. When you look at one of our websites that we've built using an Angular or React, and Webpack is a big part of that process, if you open up your development tools in Chrome or whatever your favorite browser is and you look at network traffic, instead of getting a whole bunch of downloads of JavaScript, if I can usually look pretty quickly and tell if somebody's used Webpack on the server, because what comes down is a smaller number of 3 or 4 bundles. I don't see a lot of individual, files come down from the network, and it tells me a little bit about how they built something. Webpack is nothing you install on your machine. Webpack is delivered via your favorite package manager. We use Node, we use NPM, Node's package manager. So in most of our projects, I just opened up a package.json. I assume many of you are familiar with Node. Anybody familiar with Node out there? NPM? So that's how Webpack comes down. It's a dev dependency. You don't actually deploy Webpack anywhere. It's part of your process. You'll see a whole bunch of things here. Webpack, Webpack dev server, some helpers. You see the term loader, plugin. All of these particular things go into my demo today, but Webpack is a small command line tool that is very extensible. So the people that built Webpack really just built this thing, and they came up with this concept of loaders, and they came up with this concept of plugins and entry points and outputs, and we're going to talk terminology, but other people added to the ecosystem by writing these plugins and creating plugins that do new and more creative things than the original Webpack. You don't just ever use Webpack by itself. You use Webpack in addition to other things. So I've got a sample here that just uses a few of these copy loaders. We'll talk terminology when we get into it, but I also have a little sample Visual Studio project here that's just got some simple files. This one happens to be called file1.js. It's a JavaScript file. It is very complex, one of the simplest files you'll probably see today. Just does a document write and say JavaScript file 1 is loaded. I could deploy that JS file out to a web server and add a script tag to an HTML page and have that JavaScript file come down and execute accordingly. Instead, I want to show Webpack. You know it's loaded. I just typed Webpack. Didn't do anything. It just said, you got to tell me what to do. So 2 terms you're going to hear a lot if you get into the weeds of Webpack and what we're talking about today. One is input, Webpack, or entry. Sorry, entry. Webpack, you point Webpack at a file or files in your web project and say, this is the starting point. Now, what does starting point mean to you? It's not a URL or a default page that somebody navigates to. The entry point is really the starting JavaScript file or asset that Webpack is going to start its bundle search from. What I mean by that, it's going to scan that file for, does that file have any dependencies? Ours here does not. Other ones we're going to show in a minute do have dependencies. It's going to look through that file and say, this file depends on this other file. This other file, I'm going to grab this file and the other file. I'm going to scan the other file. Does it have any dependencies? It's going to walk every line of JavaScript in your application and see what they require. And when I say require, we're talking modules, JavaScript modules, CommonJS, System.js, the new ECMAScript module system. Whether you know it or not, anybody just sit in the TypeScript class right before here? That TypeScript class, he used the import keyword a lot. TypeScript, you import one file, depends on another file. Through the import keyword, I say import this class or whatever from this other thing. That is me declaring a dependency. So a lot of what I'm going to show today is going to use TypeScript. I'm a big TypeScript fan. But here is the simplest use of Webpack. I'm going to type Webpack, and I'm going to give it an entry point. My entry point, it's a path here, but ultimately it's this file, document write. I'm going to give it an output. So I take an entry, Webpack does its thing, and it generates an output. And I've got this open. There's an empty folder here in this www root. If I hit enter, Webpack is going to do its thing. This seems like overkill, yes, for one line of JavaScript. I get some output here. It says I ran Webpack. I happen to be on version 2.10 beta 21. That might be old. I've given this demo. I really haven't updated my Webpack in a while on this particular sample. But it says I took this file and I generated an output. Let's go look at what it generated. If I look at that file, I have it open in Visual Studio Code. I just pointed it to that folder. This is that file. Some of you are wondering, what on earth? That was one. This tool can't be efficient. It went from this one line of JavaScript to 75 lines of JavaScript is what Webpack did. This code that is in this output.js, this top part, is nothing I wrote. Webpack injects this and adds this to your output bundles. Webpack keeps track of all the dependencies and writes this little boilerplate code here for you to make sure everything ties together and runs. You don't ever mess with it, don't play with it, don't edit it. It's volatile. It's going to get erased next time you run Webpack. Way down here at the bottom is my one line of JavaScript, document write. It keeps a big array. Notice this is in an array. It's an array of functions that it just calls back and forth from one to the other. And I show that day in and day out. We never look at this code. This code just runs. I'm showing it more here for purposes of explaining how the process works. To see it a little better, I have a second file. I have file 2. File 2 says I'm from file 2, and it has a require. This require is me declaring a dependency. It will pull in the contents of file 3. And file 3 just says, I'm required to be here. Now these are very, very simple examples, so I could show it. If I run that same command line, and just pick a different entry point, the only difference between entry point 1 and entry point 2, file 2, is file 2 is not standalone. The Webpack command line, if I want to visually look at it, tells me, hey, I actually bundled 2 files together into one output file. So instead of my output file has now changed, this is the bottom of my output file. It now has 81 lines here. I'm just reading the line numbers. But it has document write, I'm required to be here. This one says I'm from file 2, and it's calling Webpack required, the zero-based array of that other function. So it handles all making sure your methods get brought in and your other files get used. So that is the simplest way to execute Webpack. Give it an input, tell it where the outputs go, it's going to do it. We never use Webpack like that. It would be tedious to command line process all of that stuff. Instead, we take that same concept and we create a Webpack config. Just like anything, the nice thing about this config file is I can commit it to my Git repo. It can be used by my build servers, all my other team members, they get latest. Somebody configures this once and it gets versioned with everything else. I can go get a particular branch or a feature branch or whatever. The Webpack configuration that's current with that branch comes down with it. So this goes into our projects and this is how we configure it. The way Webpack works is they do their config as a class that they put into module export. This is the simplest version here. I can have an entry and output. These are just 2 properties or object properties of the output. Entry tells me where my input file is. I have the 1 back to file 1. Output, I give it where my output's going to go. Simple enough. This essentially accomplishes the exact same thing I just did the longhand way in the command line. So the way to do it this way is instead of giving the command line an input or an output, I can just give it --config down here at the bottom and give it a particular config file. We generally have 2 config files, maybe more, in our projects. We have one for development because we might want a particular Webpack configuration that the developers use while they're coding, while they're working on a project. When it comes time to deploy, we have different things we want Webpack to do. So we just have a development production Webpack config file. As I'll show you later as we get more advanced, we do share a lot of code. So there's some common Webpack stuff we put in, we import it into both development and production so we don't duplicate. So we can specify endpoints, terminology again, entry and output. This I'm going to truck along so I can get a lot more demos in. So some of this stuff, again, Webpack's one of those things you struggle with for a short period of time. You have to figure it out. I want to do this. The Angular team, and I bring this up because many of you said use Angular. we got to where, on my projects, we had the same Webpack config set up for every project. You know, we might be working for completely different customers, doing completely different stuff, but the general technology stack was the same. We just set all the projects up with similar folder structures so that Webpack just knew where to do with everything, and it was a best practice and it worked. Why reinvent the wheel? The Angular team kind of came to that same conclusion. They really promoted Webpack. They said, if you're building Angular 2, you know, in TypeScript or whatever, Angular 4 now, or just Angular, there's just certain Webpack settings that you should use that really work well with the TypeScript and how we set things out. So when they wrote their command line interface, Angular CLI, they said, let's just build Webpack in with best practices already set up and all the right folder structure and everything else so that people don't have to reinvent the wheel. If they want to write their own Webpack, they can, but for the most part, out of the box, create a new Angular project, Webpack is ready to go. So that's an example of heavy reuse. They did that knowing that they don't care how you use Angular. You know, everybody can be building different Angular apps, but using this tool, they just baked it in. And if you want, you can get the config files out, but you don't generally. This example is a little bit more complex thing. So two more terms. We got entry, we got output. Another term you're going to hear with Webpack is called a loader. I don't know why they came up with this term. It's a little confusing, but in the Webpack ecosystem, Webpack is extended by loaders. Loader is a file that is a, think of it as a, I don't want to use the term plugin because that's another thing, but loader is a step, all the individual files that are found as Webpack's running through your project are passed through loaders. So one example is TypeScript. I can have a loader for TypeScript. If it finds that an asset in your web project, it's a dependency and it has a .ts extension, it's TypeScript. So there's a TypeScript loader. It says, okay, this is a TypeScript file, pass it through this loader, and then take the output, and the output of that loader process is what gets bundled. What would you use a TypeScript loader for? It compiles the TypeScript. So it takes the input, the .ts file, compiles TypeScript down to JS and honors all your TS config settings, and then the JavaScript that is output is the thing that gets bundled. So every individual file, if it's a SAS file, it will run it, it'll compile it down to CSS. If it's, there's some loaders that are just raw, that just takes the input and passes it through. Every file that you want to go into your output bundle has to have a loader. What does that look like? There's a section here called loaders. I have a regular expression. I've got a loader for HTML. I've got a loader called awesome TypeScript loader. This one, there's a test. This is the regular expression for the file name. This is the name of the loader. Where do these loaders come from? They are also things that come down via NPM. So if you find somebody write a blog post about, you know, way to set up Webpack and they got a loader, they're going to have to tell you the NPM name and the version, and you're going to have to go add that back down here to your packages config. So I have, whoops, package.json. I have awesome TypeScript loader. I can use it by name. It will find those loaders in your packages folder. That makes sense. So the trick to Webpack is knowing what a good entry point or multiple, and knowing on the flip side what loaders you want to use. I've got a test down here for images and fonts. These are, if you look at that bottom regular expression, these are file types that are generally static files in a web project. There's a file loader that just moves them over. And this is a simple three loaders. So there's not much in a production. I'm going to show you some of our production Webpack stuff later. It's got a lot more. We might have 10, depending on the file types and things we want to do. Loaders run per file. So that's probably, to know the term loader, Webpack runs them per file. I've never written one myself. My usage of Webpack is just finding ones. For most web scenarios, there's already an ecosystem of these things that do whatever you want. You likely could write them very easy. The next term is plugins. Plugins happen after all the loaders, all the assets have been found, all the loaders have piped whatever they need to do on a per file basis. Plugins are kind of the final step in the Webpack process. Plugins move things around, they do different things. I've got one here called Copy Webpack plugin. This is just copies files. I give it a, move all the files from this folder to this folder. At the plugin step would be you or your team or whoever on your team doing all the final file manipulation for how you want your stuff set up. So in this case, I have a Copy Webpack plugin that just moves images to another images folder. It is worth pointing out my structure here. I guess I didn't point this out earlier. We generally never develop our projects in our www root. We build a kind of we follow most of the React and the Angular conventions. All of our actual assets in our code goes into a source folder. It's very difficult to see here in Visual Studio, but it's highlighted in my Solution Explorer. We have this source folder. All of our code, all of our images, our setup goes there. When we run, Webpack takes all that stuff, runs its loaders, generates its output, moves files, whatever we tell it to do, it does those things and moves that content into, in a Visual Studio world, what would be my www root. So there's that pipeline. That pipeline, as it's doing that manipulation, the output of all that manipulation goes somewhere else. And that means that my www root is very volatile. I can delete it on a whim. We never commit it to Git. It doesn't go anywhere. Those files, I just rerun Webpack and they're all regenerated. So we delete it all the time. We even have steps in some of our Webpacks that'll just delete the folder so we don't end up with, you know, files that are hanging because we removed something but it got regened. Or we remove something and the file just kind of hangs around and goes with places. So we don't put anything here. And in the demo, I've got a source, test files. I've also way down here got www root. There is a file in there because I've ran it a couple times. So if I run this one, I've got a TypeScript file. This is as simple as TypeScript file as you can have. I've got a TypeScript file that imports a class called person. So this is a dependency. That person is sitting here. Person.ts is also in there. I declare it and I set some names and then I write it out. Very, very simple TypeScript, but it is TypeScript. It's called file 5. If I run, clear this out. Webpack gets a little tricky to debug. They do a very good job about outputting. If I would have any errors in here, it would all show up in red. But you know, Webpack runs a lot for us, so we constantly keep an eye on it. We keep a console open. Setting it up that first time, you're going to go back and forth many times. I don't want to belittle the frustration that you're going to run into. When we make major changes, it's not like we just know what to do. We find what our goal is, and somebody might go in there and spend an hour or two tweaking it and getting it to work. Once it works, we never touch it again. We've got it set up for us. But we do spend time looking at all these red error messages like, why isn't this found, or what did I do? And the logging isn't terrible. But this particular build actually took in my TypeScript. Whoops, wherever it went. Opening a lot of files here, I apologize. It took in my TypeScript. It found file, this one. It went and found its dependency because it knows when it parses TypeScript that this import person is a dependency. So when I say an entry point in a TypeScript world, you give it the, using Angular example, a good entry point would be your app module, your bootstrapping code for an Angular app. You pointed at that. Since that module has dependencies and all the imports and all the things that it will walk your entire Angular app, pull everything together into one big file. Which might seem weird. Many of you are thinking, why would you want everything in one big file? I can minify it, I can version it. I don't code that way. My code is still all broken out into many separate individual TypeScript files. But my deployment, and as I'm debugging, it's very nice to deploy it that way. Not only does it pull your TypeScript in, it pulls in all your component front end, all your HTML. So everything is bundled, and I'll show that in a second. What does this output look like, though? I've got bundle. Way down here, my compiled TypeScript. So this is what TypeScript, this particular thing compiled looks like. It declares something. It's got exports and it writes it all out. Again, I don't generally, other than when giving a talk like this, pay particular attention to how this goes in. It works very well, but it is all compiled and all the dependencies were found. I even had a sample images folder in my source, under source, so all my assets, my CSS, my images, icons, anything, that copy Webpack plugin that ran at the end moves things for me. So another Webpack plugin that I kind of just brushed over, loaders, all my loaders were found. I have a loader for HTML, it just moves my HTML over. I have a Webpack plugin called, this is another example of something you can do. Gone are the days, at least in my world, where I spend a lot of time in my root HTML page or pages adding script tags. I don't go add a new TypeScript file over here and then add a script tag so it comes down. This HTML Webpack plugin, I give it my root HTML page, and it adds the script tags for me. It moves it into my output and adds the script tags. So I just get the path, my index.html. This is the simplest index.html possible. This is just whatever Visual Studio creates. Note, I have no script tags, I have no CSS, I have nothing. This is, in our projects we do add a title and we set it up a little more than this, but we don't add the script tags. What happens is, the end of that particular config, this step says, this particular thing says, use this as your root HTML file. Whoops, sorry, I keep scrolling. Index.html. Move it from wherever I point at into my output next to everything else and add all the script tags for me. So if I look back at this index.html that was moved over, it looks the same as the default one. The only difference is now there's this script tag down here that says type text/JavaScript source is bundle.js. So if I've got more than one output, which I'll show that and talk about why we do that, it would add multiple script tags. It can add your CSS up top. It'll add things wherever you want them to go. So that is just a Webpack plugin somebody wrote to solve that particular issue. This one is identical. So one more quick thing, and I'll switch gears, get a little bit more advanced, and show you some like my day-to-day development process and how I code. I've got a Webpack, this particular file name is webpack.file5.prod. Another thing that you can do at the end, another plugin. I'm showing just some random plugins that are common in my world, but I'm also using them as examples, hopefully giving you some sense of why you would use this tool and what they're for. I told you earlier, we have one Webpack set up for developers as we're coding. We have another one that we use during the build process. We're big into automating our build cycle or continuous integration. I got a build server. The build server gets latest of all the code out of Git. It will run all the Webpack to generate all the assets on the build server, so we script that. So this happens automated. And this particular one is the production or a sample production. The only difference in the other is it uses this webpack.optimize.uglify.js. This is very common in all of our build stuff. What happens here, I will run it. This thing runs. It does basically the same thing, whoops, except that added final step. That added final step, whoops, wrong one, minifies, it removes all comments, and it minifies my project. This is one long line of code. So now I've got one line of code. All comments have been stripped. We have a plugin we use in production that removes every document right. It removes all of our debug. It'll literally scan our code. If we've left debug code in our JavaScript, that's fine for development. We never want that code to go live. So we remove all of our console logs and everything like that. There's Webpack plugins that do an amazing amount of very cool things for your project. This one is the most common. At the end of all other plugins, minify my code. So my JavaScript my TypeScript's been compiled, all my assets have been pulled together. I didn't show it. One of these examples, file 4 pulls in some HTML. I'm going to show this elsewhere, but there, if in an Angular React world, well, React you always have your HTML. It'll do all of your TSX and JSX management for you. It'll do all of these things as part of this build process. It will embed, it'll run, it'll compile your Sass. So let me, like I said, switch gears. Here's a little fancier project. I'm just showing you a simple UI. This is Angular. Really simple Angular project that I used in another demo, so I keep it around. It's written in Angular 4, or just Angular. Again, I keep using the wrong term. If I look at my network traffic and refresh, whoops. This is my development process, how I work. I did npm start. The biggest thing that Webpack does for us is not all that cool stuff, but the thing that affects my life day to day is that cool stuff, how do I code and look at what I'm building and have all this Webpack do its thing and not introduce any errors? I need to be able to debug, right? I need to be able to run code, change code, see the output, add TypeScript, work on my web project. Webpack comes with one of the things that you can install is the second one in the list here, Webpack Dev Server. So they include a Node.js web server that will basically, I run Webpack with the setting to use that. It'll run all the other stuff, the loaders, the plugins, the inputs, the outputs, all the things that I talked about. It'll do that. And in the end, it won't just quit. It'll sit there and watch my folder. It'll attach all of the stuff that it just output to that Webpack. It'll do it in memory. So when I use Webpack Dev Server, no files are ever written. It attaches my code to my browser and lets me sit here and change. And I'll show this. Where's my console? Not that console. I got a couple consoles open here. So if I sit here, this is my code, my browser for this little project. It's an Angular project. Webpack is sitting here. It ran. You see it's a little fancier. I've got a couple inputs and outputs I'm going to show. It did vendors. I did index HTML. There's one called vendor, scripts, and main are the names of my outputs, and I'm going to talk about this because we generally don't bundle everything down to one file. We leave it 3 or 4 for various reasons. But if I change my code anywhere, this particular file, my home page, this is that home page. I don't know why I said Kevin Smith. I changed my name to Grossnicklaus. Did I spell it right? Yep. And I save. I switch back to this guy. It just says Webpack bundle is now invalid. Whoops. And it just, well, I switched gears. It switched. And now, oh, it didn't refresh for me. It has my name. If I try to get that right, Kevin Jones, and I save, it runs everything again. Should refresh my browser. Make sure I saved. I did not. Now I did. And it refreshes my browser automatically. So I get the benefit of Webpack, and I get a very handy development environment. So I have an editor. All my team sits around in their favorite web editor. We don't use Visual Studio as much as many people think. We use Webpack. We use Visual Studio Code. We use all kinds of different, or not Webpack, we use WebStorm, sorry, editors, whatever your favorite web editor is. We also keep a command line tool. We keep a command prompt sitting there at all times. Lots of IDEs anymore are building that in. If you use Visual Studio Code or WebStorm, they actually have terminals built into the IDE, and they will automatically, a lot of them even know about Webpack, and they will run and do this. But so I code over here. I keep my browser. If you've got multiple monitors, this thing attaches Webpack. So I tell you, we have a development and a production Webpack config. The development config is the one that says, open my, use this development web server, and I pick a port, and it keeps it open at this port. If I go to inspect, I'm a big Chrome fan. It works well during development. It's not the only browser we target. If I go to my sources, I'm just looking at the source. This is my Angular app. Down here, there's a section called Webpack. It actually, in development, when you're using that dev server, it does everything in memory, so it doesn't eat up disk space, or it makes it faster. It attaches it down here. I can still get to all my source. I can still see all of my TypeScript. Find that home page that just doesn't do anything. I can still set breakpoints. Let me find somewhere there's code. So I just hit a breakpoint. Even though Webpack is running, I go back over to my editor, change my TypeScript, debug, use all of these tools. Webpack reruns, and everything comes in here very nicely. So the development process is very efficient. If we're doing server-side APIs, we're a big .NET ASP.NET Core API in Azure. We've got Visual Studio running, our API sitting at one port. We've got WebStorm doing our front end in React or Angular, and Webpack is the guy that's building and packaging everything. When it comes time for me to deploy this particular project, well, let me look at this config file first. This particular project, I've got 4 JavaScript files. So we, as just a matter of practice, have kept all of our Webpack settings and config stuff in a file, in a folder in our projects called config. Different people do it in different places, but we've got prod and dev, dev being the one that has in it this open browser plugin. It's got dev server stuff at the bottom. I tell it what port I want to listen at. So down here it says there's a section for dev server. Whoops, my mouse wheel is getting away from me. I apologize. What port? It'll do its history. Port is setting. We have an open browser plugin that means at the end of the plugin, don't manipulate files anymore. Go ahead and open a browser so that we don't have to constantly do that. Then we set up the dev server, and that's in our dev. In our production deployment, we don't do that. We just want to generate the files. We generate my physical files, and we're going to push them somewhere, and then people are just going to navigate to them. We also share some common code. We have a webpack.common. We've just got a lot of little utility classes and setup that are the same in production and dev, so we use those here. We put them in a third file. Makes our life easy. We set up some constants and stuff like that. This is worth noting. I told you earlier some terminology, entry and output. We have 4 entry points. This is where Webpack gets really cool. It trims our trees. It pulls in all our vendor stuff. Vendor.ts. Vendor.ts is one of my entry points. What I mean by vendor is Angular or React or any other third-party libraries I didn't write. We pull in all these things from NPM. We have this vendor.ts where I do import, and in this particular example, I pull in all the Angular stuff. Those are my core Angular things. I'll pull them in once. I bundle, even though I'm using Angular, nobody that goes to my website sees Angular anything come down. They see a vendor.ts or JS. That vendor.js is one big file that has all of my third-party stuff, bundled, minified, everything else for it. On the flip side, I do polyfills. If you ever get stuck in cross-browser hell, polyfills, there's some great polyfill libraries out there that will basically backfill IE. We really only use polyfills because of IE anymore and some outlying things, but polyfills are JavaScript libraries that when loaded will detect the browser and ensure kind of standards compliance across multiple browsers. We don't mess with it much, but we include polyfills as our own thing. CS, we point this at my main.sas file, my SCSS file. This does all of that. And then my app. So when somebody navigates to this particular app, 5 things come down. Index.html and those 4 files. And it seems weird, but it works. So if I come here, how does this debugging work? Because the dev server knows to attach the map files to map source code back and forth. If I run this, go to network, run, whoops, hit my breakpoint, but this is what came down. Oh, there's 6. So dang it, keeps hitting my breakpoint. Refresh with no breakpoint. I hit breakpoints everywhere. Sorry. There. Refreshed. The only reason it did it twice is because I'm making an API call. So this first one is the API call. There's some WebSocket things here that are the web server, but I've got polyfills, vendor, app, and main. And then some Angular stuff down here, my API call back in JS. That was not me. That's just happening because of the Node web server. But my app is all bundled. What about all this HTML stuff in here? I mean, this thing actually has markup. That markup is embedded in that markup is pulled into those bundles. So I just searched for KCDC because I knew that I had used this in the title of that page. This is that minified. I'm using Visual Studio Code. It does word wrap, so that's the reason it all is not, there does not look like it's one line. It technically is one line because it's been minified. All of my markup, everything is bundled and minified. It strips out all your comments. It does not strip out This vendor is Angular. It does not strip out your license information. So with Angular, it does keep all the copyright data and honors all of that. But all of these things are different pieces of Angular. Each of these is likely a different file in all of the Angular builds. So here I've ran a production Webpack. It built app, polyfills, vendor, and all my CSS is in there. What is this mess? Another nice thing that you can set up Webpack to do is in your output, switch back to Visual Studio. In my output down here, wherever my output is, my production output, I can say, I don't have to give it a specific name. I can say file name, and it will use the name of the input. So this is like a tag. I could just call this, I guess in this case I got 4 inputs. So this is the name of the input, and then I put that bracket hash. It will actually run a CRC, get a hash for that individual file, and add that to the file name. It will also do that same thing when it adds the script tags. Another advantage of having the script tags get added that way. Why is that good? Because it defeats all of your browser caching issues. So if you just have an output file called bundle.js and you release a major new version of your app, bundle.js is now better because you fixed all the bugs and added all the better features, but that user doesn't see them because inevitably they're using some browser that just keeps that JavaScript file, forgets to update it. Then you have to tell the user, hold down control or clear your cache or do all of these things. When we deploy, as part of our name for our output files, we put the hash in there, have Webpack do that, and it solves it the next time we push. Unless the file contents were identical, that and one semicolon difference, that hash is going to be different. So the next time they go, they don't really care what the files are. It's all behind the scenes stuff. But for me, I'm assured that the browser will not cache that file unless it's identical. So it all works out very well. It's another little odd piece that Webpack does for us. So it bundles everything into a small number of files, and it names things, it injects things, it strips out all of our debug code. It makes it very small. When I say it makes it very small, if I look at these scripts, this is that folder, app, polyfills, and vendor. I've got 180K, 100K, and 1.1 meg for the vendor. And I could probably trim that down as well. I've just left. I went in and told it pull in all of Angular. So it took everything related to Angular and bundled it into that file. Now, assuming I don't update my NPM package, this file, I eat the cost of downloading it once. Every time I deploy, assuming I'm using the same version of Angular, this hash and this name is always going to be the same, right? So once they've downloaded that, the next time they, if I edit my code and add a feature, the only thing that's going to change is this app. This 180K is all that's going to come down. So we actually get extremely efficient throughput and extremely efficient use. That caching is one of the reasons we break into multiple outputs. See what I'm saying? If I could put all these in myapp.js, but then the issue is every time I change one line of code, I know this other file isn't changing, so I'm trying to move as much stuff that I know is static into a single file output and be efficient about that. And you can move these around. The nice thing about Webpack is, remember that first thing I showed you, that 75 lines of boilerplate code? It is extremely good about not duplicating any code. It knows that it put all the Angular stuff in this file, so it didn't put it here. Even though here depends on it, it keeps track of all its dependencies as it's building all of its outputs. And even though the outputs go into multiple files, it still knows, at some point in this app, we're calling into this file and vice versa. I don't have to worry about any of that. Webpack takes care of it for me. We write code in much the same way that we've always written code. We really fundamentally don't do anything different. We write, other than we have to know, what we do different is we keep a web browser open and we sit here and change, use our editor, and we write TypeScript, React. We do web type projects. Webpack, from project to project, we just take the settings. We know we have to keep a command line tool open. Prior to giving this talk, I went and created a little, how many of you use Angular? A bunch of you used Angular CLI. I used Angular CLI to create an empty Angular app. When I do ng-serve, I just wanted to point out that that is how they bundle their stuff. They do inline bundle, vendor bundle, styles bundle, main bundle, polyfills. We had kind of followed the Angular convention back before they built it into the CLI. That's why ours was named the same thing. We've been doing it for years. When they came out with the CLI, they just embedded pretty much what we had already been using. So we kind of just quit using our own and started using theirs. They didn't do everything exactly the same, but honestly, theirs was better for a number of reasons. So when we create an Angular app, we pretty much keep them, but the process is the same. Instead of me running Webpack with the config file to you, me running the Webpack command line, I do ng-serve, which is an Angular command line deal. Notice that is Webpack behind the scenes. It keeps this browser open and it sits and watches. It's got a file watcher. So if I did edit code anywhere, in my source folder, I edited this. If I save and go back to my browser, it beat me to it. But same basic thing. We use Webpack whether we this is Visual Studio Code.
What goes into that inline bundle?
Do what?
What goes into the inline bundle?
I don't actually know. Her question was, what goes into the inline bundle? We do vendor, we do styles, we do main. I don't know what I couldn't give you a good example. Nothing here, whatever it is, it's 0 bytes. So they emit it, but it didn't pull anything in. But they're following the same thing. If I turn around and want to do a, whoops. It's ngprod. When they build, they have a built-in build script that does the same thing. ng-serve, I forget what the build, not generate. It's my lack of using this. It's all built into our process. But they do the same kind of Webpack that we do. When you do a deployment build using the Angular CLI, they minify it, they bundle it, they add the hashes, they kind of follow the exact same setup. And that, our build servers, which is part of our build process, when a build is triggered, whether we do a commit or whether it's scheduled, at 8 o'clock at night on Project X, a build server out in Azure in Visual Studio Online will get all the code for a particular project. As part of it, it'll compile the API, the C# code, it'll compile the managed code in .NET. It will also get our web project and run Angular CLI or Webpack directly to build all the assets. It will copy all those assets into the www root folder, and then we'll do a .NET publish out to Azure VMs or a series of VMs, and then users come down. We've started to set up our projects a bit differently. We don't actually create a Visual Studio project, a web project, and put our Angular stuff in it or React. We keep them just in their own folder. And then all of our .NET stuff has managed projects and has CS-Proj and all the other stuff that goes with it. So we get to the point now where those two things don't intermingle. When Webpack runs, gets its output, we copy it into the www root of our ASP.NET Core project. But we don't actually do our development in Visual Studio that way. Questions? Yes? It does tree shaking. There's a whole, so it will eliminate anything that isn't used, which is nice. We use a tool called NSwag to generate. We pointed at a Swagger API. It'll generate all of our TypeScript proxies and all of our model classes. If we don't use them, they're not brought in. So I can have APIs that are huge, but if I never use all the inputs or outputs down in the client side, Webpack will just not embed them. It does it automatically just with the, if I point this at an entry and something isn't found, it doesn't bring it down. Right? So think of it's walking the module tree, which is an exercise in tree shaking anyway. It'll do, there's a plugin the Angular people use for ahead of time compilation. So when it gets done, it'll actually take all your JavaScript that it just minified and it will compile it down to JVM bytecode. So your compression, we do binary compression as part of our output so that the sizes get even smaller than what it comes out. You can turn stuff like that on or off. But it's one of those things, like I said, it's hopefully today you got some of the core concepts. Many of you are using it. Maybe you learned something you can go try. But it's one of those things you don't play with every day. I got guys on my team that are experts at it. I've got other guys on my team that have no idea. They know how to use it every day. They know how to do an NPM start and how the process works, but they have no idea the plumbing that's making it happen. You will see more tools. I know WebStorm does a great job. Visual Studio Code does. Visual Studio is going to start to support it more. It's becoming so popular that the ASP.NET Core team is looking at a lot of ways to make this type of development using that more native to that tool. Because right now, you do have to have a command line. You have to leave Visual Studio and do other stuff, and you're using Visual Studio just as an editor, and they're losing that war just being an editor. They got to figure out more they can do to the web people that develop like this. I know we're out of time. I'm happy to answer more questions. Like I said, email me, come up, take a card. We use this a lot. So thank you guys for coming and spending an hour of your day in this particular session.